For nearly half a century, Voyager 1 has been drifting deeper into the dark than any human-made object was ever meant to go.
In November 2023, the longest operating spacecraft in human history suddenly started speaking in tongues. Voyager 1, humanity's most distant creation, over 16 billion miles from Earth, stopped sending coherent data. Instead of science and engineering telemetry, ground controllers received an endless, repeating loop of ones and zeros. Gibberish. For 5 straight months, NASA didn't go silent. NASA was screaming into the void, trying to debug a 1970s computer from 15 billion miles away. And what they found when they finally cracked it open wasn't an alien message. It was something that might be even more unsettling. A single memory chip, smaller than your thumbnail, had been quietly dying for 46 years in the most irradiated corridor of the galaxy. And the only thing keeping this nuclear-powered robot alive was a team of engineers performing brain surgery across a 23.5-hour time delay. This is not a story about impossible signals. This is the story of what Voyager 1 is actually detecting out there in the space between the stars, and why the real data is more terrifying than anything the internet could fabricate. Let's dive in. Where Voyager 1 is right now. Let's put this distance into perspective. As of April 2026, Voyager 1 is approximately 172.6 astronomical units from Earth. That's 25.8 billion kilometers, 16 billion miles. If you sent a radio signal right now, traveling at the absolute speed limit of the universe, the speed of light, it would take over 23 hours and 31 minutes just to reach the spacecraft. One way. A round-trip conversation takes nearly 2 full Earth days. The probe is hurtling outward at roughly 17 kilometers per second. That's 38,000 miles per hour. It crossed the heliopause, the boundary where the sun's protective magnetic bubble ends and interstellar space begins, back on August 25, 2012, at a distance of about 121 astronomical units. Since that day, Voyager 1 has been sailing through the very local interstellar medium, the actual space between the stars. No spacecraft has ever done this before. No spacecraft currently in operation will do it again in our lifetimes. And here is where it gets critical. Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs, that convert the heat from decaying plutonium-238 into electricity. When it launched in 1977, those generators pumped out 470 watts combined. Today, after nearly 50 years of relentless radioactive decay and thermocouple degradation, the power has dropped below half of that. The spacecraft loses roughly 4 watts per year. It is bleeding out in slow motion. As of 2026, only 3 science instruments remain operational: the magnetometer, the low-energy charged particles detector, and the plasma wave subsystem. The cosmic ray subsystem was shut down in February 2025 just to keep the lights on. Every instrument that gets sacrificed buys the others a few more months of borrowed time. The 2023 to 2024 crisis. What actually happened? Now here's the part the internet turned into an alien conspiracy. On November 14, 2023, the data coming back from Voyager 1 suddenly stopped making sense. The Deep Space Network still had a clean lock on the spacecraft's radio carrier signal. Voyager was alive. It was pointed at Earth. Its survival systems were running, but the data payload was completely corrupted, just an endless repeating pattern of meaningless binary. Mission controllers at JPL were effectively flying blind. No science data, no engineering telemetry, no way to check the thermal state, the power margins, or the fault protection systems of a spacecraft older than most of the engineers trying to save it. They narrowed the problem to the Flight Data Subsystem, the FDS. This is the central computer responsible for collecting raw readings from every instrument and sensor on board, formatting them into data packets, and handing them off to the transmitter. The FDS was a marvel when it launched. It was actually the first spacecraft computer ever built with volatile CMOS memory chips instead of the heavier magnetic core memory used in earlier missions. Faster, lighter, but vulnerable. 46 years of cosmic radiation had finally caught up. On March 1, 2024, engineers sent a specialized command forcing the FDS to dump its entire memory contents back to Earth. 2 days later, when the signal arrived, they found the culprit. One single physical memory chip, representing about 3% of the total FDS memory, was permanently dead. Either a galactic cosmic ray had fried the silicon, or the hardware had simply degraded after half a century in deep space. Here's where it becomes genuinely extraordinary. You can't replace a chip 16 billion miles away. So the JPL team had to perform something that can only be described as remote neurosurgery. They broke the corrupted software into smaller fragments, scattered those fragments across every remaining healthy pocket of memory in the computer, then manually rewrote every internal pointer so the fragmented program could still execute as a single coherent operation. On April 18, 2024, they transmitted the patch. 2 days of silence. Then on April 20th, the repeating gibberish stopped and clear engineering data flowed for the first time in over 5 months. By early June, all remaining instruments were back online. Voyager 1 had survived. If you're fascinated by what's actually happening at the edge of interstellar space, make sure you subscribe and hit that bell so you don't miss the next chapter. Because what Voyager is detecting out there right now is going to change how you think about the space between the stars. What Voyager 1 is actually detecting. Now here's the thing nobody talks about. What Voyager 1 is actually measuring in interstellar space is genuinely strange. Not alien signal strange. Physics-defying our models strange. Before Voyager crossed the heliopause, scientists expected interstellar space to be a quiet, static void, dead empty. What they found was the opposite. The plasma wave subsystem detected a faint, persistent hum, a continuous, narrow bandwidth plasma oscillation that researchers published in Nature Astronomy in 2021. This is not sound. Space is a vacuum. But the plasma out there undergoes constant microscopic oscillations, a kind of background vibration that lets scientists continuously measure the density of the interstellar medium in real time. And that density was the first shock. The interstellar medium turned out to be roughly 40 times denser than the hot solar wind just inside the heliopause. Space between the stars is not empty. It is a thick, dynamic ocean of charged particles. But here's where things get really interesting. Even though Voyager 1 is completely outside the sun's protective bubble, it still feels our star. Massive solar eruptions called coronal mass ejections send pressure waves rocketing outward. When those waves smash into the heliopause boundary, they act like a drumstick hitting a membrane, launching compressional shocks deep into interstellar space. Voyager 1 has flown directly through several of these interstellar shock waves, recording dramatic spikes in magnetic field strength and plasma density in 2012, 2014, and a prolonged pressure front beginning in 2020 that persisted for years. And then there's the magnetic field mystery. Theoretical models predicted that once Voyager crossed the boundary, the magnetic field direction should rotate to align with the pristine interstellar field of the Milky Way. It didn't. The field intensity jumped, but its direction remained stubbornly aligned with the sun's magnetic field. Scientists now believe the interstellar magnetic field is essentially draped around the outside of the heliosphere, like a rubber band stretched over a beach ball. Voyager is traveling through a distorted boundary layer that may take years to fully escape. The impossible signal myth. So let's talk about the elephant in the room. The internet is saturated with videos claiming Voyager 1 has detected alien transmissions, intercepted impossible signals, or received self-replicating commands from a mysterious source. Some of these videos clock in at over an hour long, maximizing ad revenue on pure fabrication. They claim NASA went silent out of fear. They claim astrophysicists are baffled beyond comprehension. Here's the reality. Voyager 1 does not listen for alien signals. It carries no radio telescopes. It has no SETI-style receivers. It has no microphones. The spacecraft is equipped exclusively with instruments designed to measure localized physical phenomena, plasma densities, cosmic ray impacts, magnetic field strengths. Its communication system is hardwired to transmit on a single X-band frequency, sending its own instrument data back to Earth. It is physically incapable of receiving, processing, or relaying external interstellar radio transmissions. What these conspiracy channels actually do is monitor NASA press releases for real anomalies and then repackage them with science fiction tropes. When the FDS memory chip fails and produces corrupted binary, they spin it as NASA intercepting an alien binary message. When JPL takes 5 months to carefully diagnose a hardware fault from 15 billion miles away, they claim NASA went silent to hide the truth. In reality, NASA and JPL continuously and publicly publish every mission status update. Total transparency. Every engineering decision, every instrument shutdown, every software patch is documented and released. The irony is crushing. The fabricated stories about alien signals are infinitely less interesting than the actual truth that a team of aging engineers is keeping a nearly 50-year-old nuclear robot alive in the space between the stars by hot-wiring fragmented memory chips across a 23.5-hour communication delay. The final years and the light day milestone. Now see, here's the part that genuinely keeps astrophysicists up at night. Voyager 1 is dying, and there is nothing anyone can do to stop it. The plutonium-238 in those RTGs follows an 87.7-year half-life. The raw thermal output is continuously decreasing. On top of that, the thermocouples themselves are physically degrading after decades of extreme heat and radiation exposure. Current engineering estimates suggest Voyager 1 will drop below the minimum power threshold required to operate any single science instrument somewhere between the late 2020s and the early 2030s. After that, it might still transmit basic engineering health data for a few more years, and then the signal will drop out forever. But before that happens, Voyager 1 is about to cross a milestone that will make your skin crawl. In November 2026, the spacecraft will reach approximately 173.14 astronomical units from Earth. At that precise distance, a radio signal traveling at the speed of light will take exactly 24 hours to make the crossing. Voyager 1 will become the first human-made object to be one full light day from its creators. And there's already a plan for what comes next. The Johns Hopkins Applied Physics Laboratory is leading a conceptual study for an interstellar probe, a purpose-built successor designed to reach 400 astronomical units within 50 years using advanced propulsion techniques. The proposed launch window opens around 2036, but that mission is still in the advocacy phase, dependent on NASA funding that has been turbulent in recent legislative cycles. In the meantime, Voyager 1 is it, the only direct sampling instrument humanity has ever placed in interstellar space. The golden record and the silent journey. After the power fails and the last instrument goes dark, Voyager 1 will not stop. It has permanently escaped the gravitational pull of the Sun. It will coast through the Milky Way galaxy, essentially forever, carrying a 12-inch gold-plated copper disc bolted to its exterior. The Voyager Golden Record. Curated by a committee chaired by Carl Sagan, that record contains 115 analog-encoded images of life on Earth, greetings spoken in 55 languages, recordings of human brainwaves, natural sounds from thunderstorms to whale songs, and 90 minutes of music spanning Bach, Beethoven, Chuck Berry, Navajo chants, Peruvian panpipes, and Georgian choral singing. The cover is engraved with playback instructions, a pulsar map showing Earth's location, and a patch of ultra-pure uranium-238 electroplated as a radioactive clock, allowing any future civilization to calculate exactly when the spacecraft was launched. In roughly 40,000 years, Voyager 1 will drift within 1.6 light-years of a small red dwarf star called Gliese 445 in the constellation Camelopardalis. It will orbit the galactic center essentially undisturbed for billions of years. Long after the Sun has consumed the Earth, that golden disk will still be out there, a frozen monument to a species that once looked up and refused to stop reaching.